In this video, I'm going to do a number of examples from section 2.6 on function composition. The definition for function composition, it's written f circle g like this. We create a new function. We call it f composed with g, or the composition of f with g. If we want to plug a number in, we want to plug an x in, we first plug that number into g, take that output result, and plug it into f. So the formula is f of g of x. Okay, we're feeding one function into another. Okay, so now let's look at several examples. We're given three in this number 4 functions given by tables f, g, and h, and we're going to compute some composition. So to do the first one, f composed with g of 1 is defined to be f of g of 1. We got to first compute the output g of 1. Go to 1 in the x column, the corresponding output is 2, so we're looking at f of 2 really. Go into the f table, go to x equals 2, the output is 1. So f of g of 1 is 1. F composed with g of 1 is therefore 1. If I want to do the next one, I'm going to plug in 3. F composed with g of 3. Got to go 3 in the g column and the x column. For the g table, the output's 1, so we're now trying to find f of 1. The corresponding output is 4. So let's run through the rest of these, maybe do some of these a little quicker now. Plugging in 1 to f, we get the output is 4. Plugging the input 4 into g, we get the output being 3. Okay, the next one, we want to plug 3 in to f first to get the output 2. Take 2, plug that into g, get the output 4. Now if we want to do f composed with itself 4, we're going to plug in 4 to get 2 initially, plug 2 back into f to get 1. Alright, so our output is 1 there. F composed with itself at 2, we plug in 2 to f, we get 1, plug in 1, then get 4. Okay, if we want to do g composed with itself and plug in 2, plug in 2 first to get 4, take the output 4, plug it back into g, get the output 3. For the next one, we've got a triple. We're going to do a very similar thing. We're just going to take the 2, plug it into h, take that result, plug it into g, take that result, plug it into f. So we're going to be looking for f of g of h of 2. To find h of 2, go to the h table and compute that output. It's 3. So now we're really trying to figure out f of g of 3. Okay, now go to the 3, find 3 in the x column for the g table. The output is 1, so now we're trying to compute f of 1, and we know that is 4. Okay, so f of g of h of 2 is, finally after all that, 4. And then we'll just do the last one. To finish the list off, we're going to plug 2 into f first, then to g, then to h. So we plug 2 in and get 1. Plug 1 into g and get 2. Plug 2 into h and finally get 3. Okay, now moving down to the ones at the bottom of the page, we see we've got, want to compute several different compositions. These ones, though, are not given by tables. They're given by formulas. So let's compute f composed with g of x. So we take f of g of x, and we're going to look at number 6 here. F of g of x, well, g is 2x plus 5. Now to figure this out, it's a little confusing because there's all these x's all over the place. Write down the action of the function f. It takes 3 and subtracts off its input. The new input is 2x plus 5. So it's 3 minus the quantity 2x plus 5. To simplify that, we're going to distribute the negative sign through, and we have 3 minus 2x minus 5. Oh, that's supposed to be a 5. Okay, so let's fix that. 3 minus 2x minus 5. Now we're looking at is negative 2x minus 2 is our final answer. To go the other way, we're going to do g of f of x. Okay, and that's g of f of x, which is 3 minus x. Again, the best way to do this is to write down the action of the function by replacing the variable, in our case x, by an open parenthesis. So it's 2 times the input plus 5. The new input is 3 minus x. So we get 2 times 3 minus x plus 5. Now we're going to distribute the 2 through, and we get 6 minus 2x plus, that's supposed to be a 5 there. That's my fault. Okay, so I'm just anticipating the answer there a little bit. So it's really 6 minus 2x plus 5, which is 11. So our final answer is negative 2x plus 11, or 11 minus 2x. Okay, moving on, let's take a look at number 8. We're going to do the compositions each way. F of g of x, we're going to take the formula for g, which is 5x squared minus 2, plug it in to f. What does f do? F multiplies its input by 4 and then subtracts off 3. Our new input here is 5x squared minus 2. So we're going to do 4 times the quantity 5x squared minus 2, then subtract off 3. Distribute the 4 through, and we get 20x squared minus 8 minus the 3 trailing at the end. So our final result after we combine like terms is 20x squared minus 11. Going the other way, it's going to be a little bit more work. G of f of x is 4x minus 3, so we're trying to do g of 4x minus 3. It's going to be more work because we've got to square something now. What does g do? G multiplies 5 by its input squared and then subtracts 2. Our new input for this one is 4x minus 3. So we're going to have to square the binomial 4x minus 3. To do that, write it down next to itself, multiply it by itself. We get 5 times 4x minus 3 times 4x minus 3, and then finally minus the 2. We're going to multiply each term in the first polynomial by each term in the second, and then add the results. We get 16x squared. Okay, and then we get negative 12x on the outside and on the inside, giving us a total of negative 24x plus 9 minus 2. Now distribute the 5 through, clean it all up. We get 80x squared minus 120x plus 45 minus 2. And then lastly, just add their numbers. Our constant terms are the only ones we can combine. We get 80x squared minus 120x plus 43 is our final answer there. Next, let's take a look at number 11. So I've got part of it written out here. We want to do f of g of x. We're going to plug in the formula for g, which is 1 over x. The function f does the following. It takes 2 and divides it by its input plus 3. Our new input is 1 over x, so we're going to have 2 over the quantity, 1 over x plus 3. Okay, now to simplify that expression, what we're going to do is multiply the top and bottom by the LCD of the denominator. The least common denominator is x in our case. We're going to multiply top and bottom by x to clear the fraction out to make it a non-complex fraction. Multiply each term by x. We get 2x on top. 1 over x times x is just 1 plus 3x. And that's our answer when we do f composed with g. That's the harder part for this one. If we go the other way and we feed the function f into the function g, we have g of 2 over x plus 3. Now g takes its input, whatever it is, and does 1 divided by that input. Our input for this problem is the 2 over x plus 3, so we're going to stuff that in and then simplify. To simplify, we basically just need to flip that up. We're taking a number, 1, or one fixed quantity, we're dividing by a fraction, and whenever we do that, we change it to multiplication by the reciprocal. So we're going to have the numerator 1 times the reciprocal of the denominator, and that gives us x plus 3 over 2, which is the same as 1/2 x plus 3/2. Okay, so either one of those is an acceptable answer for this question.